So we're continuing on with examples of different types of t-tests in the context of energy and pollution. And the next example that I want to look at is one where we've got two groups. So we're going to say that, look, let's compare electricity use on a daily basis for households that are all connected to electricity for their energy supply rather than a mix of electricity and gas. And we're going to compare two groups. So just randomly pick WA and Victoria. Okay, steps that we're going to go through. We're going to create a plot. We've got two groups, so we would be looking for a box plot. We've got a null hypothesis and an alternate hypothesis. The null hypothesis is that WA and Victoria daily use are equal. We're going to have an alternate hypothesis as well, which is that they're not equal. We're going to have alpha set to 0.05. We're going to conduct a two-sample t-test. But remember that we need the variance ratio test first, and for all of these things that we're going to apply our p-value decision rule. And then at the end, of course, we want to be able to say something interesting about this outcomes. So what have we got? We've got our plot. Now I'm eyeballing the plot. All right, so eyeballing the plot, what does it say? It says that, well, it's looking like the spread, so the middle 50%, the spread is looking maybe a bit bigger in WA, but also I've got that long tail in Victoria. So I'm actually not sure about that. The variances might be the same. And then I've got the mean. So I'm actually looking at that and thinking, yeah, okay, Victoria does look a little bit lower than WA. That's just informing me, and that's really going to be an essential part of you convincing a reader of your story. All right, so your story consists of the text that you write, the plots that you create, and the summary tables that you present to, really emphasize some key points. Okay, so we need to know which t-test to use for our formula. So we apply the variance ratio test. So remember, we've got three types of t-tests. The only time that we want the variance ratio pre-t-test is when we're doing the two-sample t-test. The variance of the WA sample is equal to the variance of the Victorian sample. That would be our null. Our alternative is that they're not the same. Alpha is 0.05, so that really just means that that's our p-value decision rule, and we're going to apply it and reach a conclusion. So we're starting to get the hang of this. We apply this with the Energy 1 dataset, apply the variance ratio test to the two variables WA1 and Victoria1, and we're going to look at the p-value and make a decision. So this time the p-value is above 0.05, therefore we do not reject the null of equal variances, which means that for our t-test, we're going to apply the equal variance formula. All right, that's okay. We just needed to know that information to know what kind of t-test to apply. What's our null and our alternate? So the means are the same as the null for the t-test. The alternate is that the means are not the same. So I've, kind of given you a few ideas on how you could express these. I'm pretty relaxed as long as it's clear in this sort of setup. Apply the p-value decision rule. So let's go ahead, apply our t-test, which we're getting good at doing now here, with the data set, apply the t-test, WA and Victoria, variances are equal. This statement is true. So please use the formula where the variances are equal. And you can see here our t-test, the p-value is less than 0.05. So we would conclude there is a difference, okay? And again, the whole point about this is not to stop at saying I've found a statistically significant difference. It's then to go on and say, okay, is it environmental conditions, or is there some policy factor? Maybe the housing standards in Victoria are different to in Western Australia, and that's led to people using less energy. Or what are the driving factors behind it? Okay, so the point of the test is to inform some policy, and that's an opportune time to have a